Hello and welcome. And today, as you can see, I've now moved up in life. I now have a whiteboard rather than a chalkboard. And today we'll be looking at transpulmonary pressure. Now, before we can start looking at that, really what we have to do is look at the different pressures that we have both in the atmosphere and the lung. So let's first draw a lung. Oh, it's not clear at all, is it? Let's now draw a lung, like so. Okay, and so imagine this is our thoracic cavity. We have our trachea coming down, and we have lung here, and a lung here on the other side. Now, surrounding the lung, of course, on this area, not quite to scale, but this area here is what we call the pleural cavity. Here, of course, is the alveoli and part of the lungs. And up the top here, we have the atmosphere. Okay, way up the top, too far. The atmosphere. And so the atmospheric pressure, we're assuming standard temperature and pressure, is equal to 760 millimeters of mercury. The pressure in the alveoli will change depending upon the volume of your lungs. As you increase the volume of your lungs, you'll decrease the pressure in the alveoli due to, of course, Boyle's law, the old P1 V1 equals P2 V2. So hence, if we increase volume, we're going to decrease the pressure. Okay, so we have these pressures, 760 here. We don't know what this is, and we also have the pleural cavity pressure. Now let's say take a point where you are just about to breathe in. So there is no airflow between the atmosphere and the alveoli. If there's no airflow between these two, then the pressure in the alveoli has to be the same as the atmosphere, 760 millimeters of mercury. Okay. Now what we like to do, and sometimes what you'll see in textbooks, is we say that atmospheric pressure is equal to 0, so we relate everything to it, so it's all relative. So 0 here, 0 here. What about the pressure in the pleural cavity? Well, the pleural cavity is special because its pressure is going to be less than atmospheric. And the pleural cavity, when you're about to breathe in, its pressure is normally 756 millimeters of mercury or -4 millimeters of mercury. Now, the reason for this is that the pressure in the pleural cavity is what helps to keep the lungs inflated. The lungs have pressure within them that wants for them to collapse. The two major factors leading to this pressure inwards and wanting the lungs to collapse is firstly the surface tension produced by the water that lines the lungs of course being a moist surface, and that of course is slowed down, or that surface tension is decreased of course by the surfactant. But there still is the surface tension there even though surfactant is present, and it still wants to collapse the lungs. There is also the natural recoil of the lungs. The lungs have natural recoil because of the elastic fibers, so they too want to make the lung get smaller. So in order, therefore, at this point in time, between breaths, just before inspiration, when there's no airflow in, the lungs still remain inflated. Now, the reasons why they stay inflated is, at this point in time, you must have an equal and opposite force. You must have a force that is going in the opposite direction. And this force will then keep the alveoli open. So here we can see the pleural cavity pressure is -4. The alveolar pressure is 0. So the pressure difference between these two is 4 millimeters of mercury. And the direction, of course, pressure going from high pressure to low pressure, the direction of this transpulmonary pressure force is outward. So the transpulmonary pressure is equal to alveolar pressure minus the pressure in the pleural cavity, which we call pressure intrapleural. And so it's equal to 0 minus 4, so it's equal to plus 4 millimeters of mercury. And it's this transpulmonary pressure that keeps the lungs expanded at this time. So therefore, if pleural cavity pressure was to go to 0, for example, if you put a hole in the pleura and air is able to rush in from the atmosphere, making pleural cavity pressure 760, you'd no longer have this pressure opening the alveoli. The pressure would be going inwards and your lungs would collapse. So on that happy note, we'll finish talking about the transpulmonary pressure.